And so in our last lesson, we ended up doing the last problem as finding the derivative of this square root of x plus 1. And then we use that to find the slope of the tangent line at x equals 8. And when we did that, as you may recall, we ended up finding that we got an answer of the slope being 1/6. So we got a slope of 1/6 for that. Now, we want to use that slope to find the equation of the tangent line. We found the slope of the tangent line. Now we're going to write the equation of the tangent line. So, that means I need to have the coordinates of the point that this goes through as well. Now I know that x equals 8. If x equals 8, what does y equal in this problem? It does equal 3. Now, how would I know that? I'm just trying to figure out what f of 8 is. And so we do the square root of 8 plus 1, which gives us the square root of 9, which is, of course, 3 then, yes. So that tells me that this point is going to be 8 comma 3, and we know we have a slope of 1/6, so please write the equation of the line that goes through that point with that slope. Alright, so in order to do that, of course, the tangent line is a line. Tangent is always a line. So we're going to be plugging it into the old y equals mx plus b kind of an equation. In this case, I know that y is 3, m is 1/6, x is 8, and b is what I'm trying to figure out. So, let's go ahead and then do that work here. So that gives me 1/6 times 8. That gives me 8/6, which I'm going to go ahead and reduce to be 4/3 here at the moment. So 3 equals 4/3 plus b. And so then we would subtract 4/3 from both sides. 3 minus 4/3 should give us, you can either give it as 1 2/3 or 5/3. Either way would be fine here. Since this is a b value, I'm going to write it as 1 2/3. That's a personal choice. And so then we end up with an equation of y equals 1/6 x, because I want the slope, of course, to stay in there, but x and y, they can change. This is the equation of a line, plus our b value, and our b value here was 1 2/3, or, again, 5/3 if you wish. And so today's theme really is going to be continuing with that idea of writing the equation of the tangent line. And so here's a new equation, and I want you to please find the slope of this line using the derivative, and of course it's going through this point here. And then once you find that slope, write the equation of the tangent line. And of course we could approach this two different ways. We could do it by figuring out what f of x plus h is, or we could use the x value we're given, which is 2. We could do f of 2 plus h. Either way would work in this case. I'll tell you, I just make a habit of doing it for x plus h, so that's the way I'm going to show the work. And so if you are doing it with the x plus h in there, this is what that first step is going to look like. Again, notice I'm including that limit as h approaches 0 in front of it. It's easy after doing all that difference quotient work that we've been doing recently to forget about the limit, but the limit is what's making it the derivative. And of course that's what we're interested in here, is the derivative. Now I've skipped a few steps there so you'd actually show the work in between to get there, but then that is what we end up getting when we simplify the difference quotient part of it, and then we next go and find the limit as h approaches 0. And so then when we find the limit as h approaches 0, we can just use direct substitution there, so I plug the 0 in for h. And so then that gives me 10x. That's the general derivative, f of x, or f prime of x. But of course, we're actually looking for the slope at that particular point. Remember, we're looking for what's happening at 2. So then I'm going to go ahead and figure out what is f prime of 2. And so that means I'm going to do 10 times 2, which means that f prime of 2, the number that I've been looking for here, equals 20. That is the slope of our tangent line right there. Because remember, derivative means slope of the tangent line. All right, now we go into part B. We find our equation now of the tangent line. So I already have the slope being 20. And so then I also have this point up here at 221. So I plug that into y equals mx plus b. The y is 21. So I go 21 equals m, the slope is 20, times x, which is 2, plus b. And go ahead and figure that out. So 20 times 2 is 40. Subtract the 40 from both sides. We end up getting negative 19 equals b. Therefore, our equation, the part that we're looking for here, the equation of our tangent line is y equals 20x minus 19. All right, so let's check in, see how you're doing on this. So we're first in this problem, find the slope using the definition of the derivative. In other words, figure out what f prime of x is, and then we're going to plug the x equals 4 in there. You'd show all the work to get there, but to show what you should be ending up with at the end, you should be finding that f prime of x equals 2x minus 3. And so if f prime of x equals 2x minus 3, then we can plug the 4 in there. So we're finding f prime of 4. That is the slope at 4. And when we do that, we should find that it gives us 5. So the slope of our tangent line here should be 5. Now, use that to, or actually, no, don't use that yet. In part B, find the coordinates of the point. When it says use the function to find the point, it's saying the original function up here. So take the x equals 4, figure out what f of 4 is. Because we're going to need that y value in order to find our equation. And when we plug 4 into the original equation here, we end up finding that f of 4 equals 5. Happens to also equal 5, just happens to be that way. So then, in order to find my equation of my tangent line, I am going to go y equals mx plus b. And so notice that y was the f of 4 value that I found. Slope was the derivative. And x was our x value that we started with. All right, so then we figure out what that is. So 5 equals 20 plus b. Subtract the 20 from both sides. So we got b equals a negative 15, which means our final equation here is y equals 5, because of course the slope is still the slope there, x minus 15. And so for doing this one, again, we still start by finding the derivative, because if I'm going to write the equation of the tangent line, that means I've got to find the slope, and that means derivative. And so this is what your first step looks like when we plug it into the difference quotient, and we find the limit as h approaches 0. And so then, in order to deal with those nasty square roots on top, I'm going to go ahead and multiply top and bottom by the conjugate of the top. So this is what your work should be looking like for multiplying by that conjugate. And then go ahead and do that multiplication. Remember, the beauty of multiplying by the conjugate is that where I multiply conjugates together, basically I'm going to square the first term and I'm going to square the second term, which, when they're both square roots, just makes those individual square roots go away. And don't worry about distributing that h in on the bottom, just leave it factored out, because we're going to be hoping here in a moment that we're going to be able to cancel that out. And leaving it factored out makes that even easier to see if we can actually pull that off. And so, after I simplify the top, can I cancel out the h's? Yes. And when I cancel out the h's, what is left on top? 1. Because, of course, remember, there has to be something left on top, and h divided by h gives us the 1. All right, so fully simplified, this is where we end up being left. So we have f prime of x equals the limit as h approaches 0 of that fraction with the square roots in it. Now that I've actually simplified it to the point where the h in the bottom went away, we canceled it out, I can now go ahead and plug the h in, plug the 0 in for h, to see what that's going to go ahead and give us. So f prime of x is going to equal 1 over, plug 0 in for h. So that gives me the square root of x minus 2 plus the square root of x minus 2. Well, in the bottom I have the square root of x minus 2 plus itself. It's plus itself, right? So what's a shorter way to write it? 2 times it, yeah. And so it ends up being 1 over 2 root x minus 2. There's our derivative function. Now remember, though, that this is actually just the first step of this particular problem, because this problem was asking us to write the equation of the tangent line through this point, through the point 6, 2. So now that you know this, how do we find the derivative? Now use it to write the equation of the tangent line. That means first find your slope, then your y-intercept, and proceed from there. All right, so if we know we're going through 6, 2, the first thing I want to do is I want to figure out what f prime of 6 is going to be, because I want to know what is the slope when x equals 6. So I'm going to do 1 over 2 times the square root of the 6 minus the 2. Thankfully, that's going to work out to be a nice, pretty number, because the 6 minus 2 is 4, and the square root of 4 is 2, so it's 1 over 2 times 2, which gives me 1/4. So I know f prime of 6, that is the slope of my tangent line at 6, is 1/4. And now I can go ahead and figure out the equation. I just got one last step in doing that. It's going to be y equals, so that's going to be 2 equals, mx, so that's slope, 1/4, times our x value, which is 6, plus b. Because I'm trying to figure out what the y-intercept is now, and I just do it by plugging in, figure out what that's going to give me. So that gives me 2 equals, so that's 6/4, which reduces to be 3/2, plus b. So we subtract the 3/2 from both sides. You should end up finding that b equals 1/2. So we get then a final equation of y equals 1/4 x plus 1/2.